we started working with radicals, right? Radicals, there's parts of the radical we talked about. The first one is the radical sign, the actual sign. The number on the inside or whatever's on the inside is called the radicand. You're going to see that word a lot. Okay, so that's why I put it up here. It's in your notes too, but just in case. The number out here, right? What tells us we're looking for pairs or triples or whatever it is. It's called the root or the index, right? If it's not there, it's a square root. We're looking for pairs. And then the number in front is called the coefficient. Okay, the number in front is called the coefficient. Okay, so today we're going to be doing some operations. Operations in math are four things: adding, subtracting, multiplying, dividing. Okay, we did some of that last time too. We're not going to focus today on the division part. We're just going to focus on the first three: adding, subtracting, multiplying. And you guys actually did some multiplying on the last assignment. Okay, so the first one is adding and subtracting. All right, so adding and subtracting. So if we're adding and subtracting anything, they have to be like terms, right? So you don't have to write this part down. Don't write this part down yet. But if we're adding or subtracting two numbers, so if we're adding like a -8 plus 6, right? We can add those two numbers to make -2 because they're both numbers. They're both constants. They're both don't have any letters with them or anything, right? What if I changed it this way though? What if I said -8x plus 6x to the second power? Could I add those to make -2? No, I can't, right? I can't add them together. What we say is this is simplified as far as it can go, right? But if I changed it to look like this, now those are like terms, right? And when I add them together or subtract them, what's the only thing I'm adding or subtracting? What would be the answer if I was adding or subtracting those? -2x, right? So all I'm adding or subtracting are the -8 and 6. The x just stays the same, right? I don't do anything with the x. It just comes along, right? It's the same thing we're going to do today. Okay, it's the same thing we're going to do today. All right, so let's go back to our problem here. So my question is, can I add 8 plus 6 right now? I can't. Why not? For the same reason I couldn't do it in the middle one. They're not like terms. They're not like terms. This one over here, it looks like terms, right? They're both square roots, right? But what's in the roots? Are the radicands the same? No. The radicands have to be the same for you to be able to add them. Okay? Well, let's try simplifying it. 3. The first radicand is 3, the number on the inside. Can I simplify 3 using the tree? No. Because 3 is just 3 times 1, right? 3 times 1 is just 3. Okay? So I can't simplify that one, but let's try simplifying 75 using the tree. 75 I think will work, right? What can I use? What goes in, or what makes 75 using multiplication? 25 times 3, that's one of them. Sure, we can start there. 3 is prime, can't be broken down. And then 25 is 5 times 5, right? So 8 times the square root of 3 can't be broken down. We said that. But this part can. I can change this, right? I can change this to 5 times 5 times 3. And then, are there any pairs in there? Yeah. We got pairs of 5s. So what can come out? If I have a pair of 5s, what can come out? A 5 can come out. Why can a 5 come out? Because when I multiply these two guys here, I get 25, right? And 25 is on my list. 25, the square root of 25 is 5, which is the one that comes out. And what does it do with the 6? When the 5 comes out, what happens to it in the 6? multiplied together, multiplied together. I cross this guy out because I'm done with those pair. So now what I have is that. 6 times 5 is 30. Once I'm done with those pair, I only got 3 left. 3 is the only thing left in there. Okay, so that's why it's square root of 3. Now they're like terms. Now they both have the same square root, 3. So now I can add them together to make 38 times the square root of 3. Okay? I couldn't do that before because they weren't like terms. But once I simplified them, then I could figure that out. Then I could say, oh yeah, I can add them. Okay? All right, so let's look at the next one, number 2. This one's subtraction. Same type of question, but it's subtraction. So before we do anything, do we have any, what are the coefficients in front? What are the coefficients? They both have a -1, right? That's always important, especially for these guys, because we got to know if anything comes out in front, we got to know what to multiply it with. So 72 and 200, they're not like terms, but they might have pairs in there. So I want you to break down 72 and then break down 200. Do that right now. See what you get. Look for pairs. Simplify it, just like we did last Friday. So break down 72 and break down 200, just like you did last week. So for 72, you get 3 times 3 times 2 times 2 times 2. 2 3s and 3 2s. All right. And then for 200, you get 5 times 5 times 2 times 2 times 2. You get 2 5s and 3 2s. Okay, so now we're looking for pairs. Okay, so once we broke it down, let's go back in and circle pairs. I got a pair of 3s over here. I got a pair of 2s over here. Then over here, I got a pair of 5s and I got a pair of 2s. Both of them have 2s left over. Okay. So the first one, I got a pair of 3s. So if I got a pair of 3s, that's 9. That's 9. 3 times 3 is 9. The square root of 9 is 3. So that means I can bring out a 3. And it's going to multiply with whatever's in front. Cross that out because I don't need it anymore. And then I got a pair of 2s. 2 times 2 is 4. The square root of 4 is 2. So I got a 2 that can come out. Cross those out. Okay, I'm going to do the same thing for the other one. I got a pair of 5s. 5 times 5 is 25. So I can pull out a 5 because the square root of 25 is 5. Cross those out. And then I have 2 times 2, which is 4. The square root of 4 is 2. So I have a 2 that I can take out of there as well. So a lot of different things I could take out. The first thing, I took out a 2 and a 3. Well, that's going to be multiplied. All of these guys here are going to be multiplied together. 2 times 3 times -1 is -6. And I have a 2 left in the middle, or on the inside. So I got to write that square root of 2 down there. Over here, I had -1 times 5 times 10. Or sorry, times 2. -1 times 5 times 2. Multiply those, you get a -10 or a -10. And there's a 2 on the inside, right? Okay. Now they've both been simplified. Now, it turns out that they both have square root of 2. They're both like terms. So I can add or subtract the coefficients. The coefficients are the numbers in front. So I get -16 times root 2. Okay, so when you're adding or subtracting, simplify, combine like terms. Those are the only 2 steps. Simplify the inside. Once you've done that, then add or subtract the coefficients. Okay. All right. Okay, so that's adding and subtracting. So now let's go to the inside of the of your booklet, of your notes. Now that's multiplication. So now we're going to do some multiplication. Okay. Okay, so multiply here. This one, how do we know we multiply? 2 reasons. A, there's nothing in the middle here, right? There's no plus or minus in here, right? So if there's nothing on the between parentheses, it means multiplication. The second reason it says product. Product means you're going to multiply. If you get a product, that means you multiply. Okay. Okay, so here we have a binomial because it's got 2 terms. 2 terms. And same thing with here. The only difference is one is subtraction in between and one is addition in between. So we did this back last chapter. We multiplied binomials times binomials. What did we use when we did that? Multiplication box. It says right here, multiplication box. Okay. So since it's a binomial times a binomial, I need a 2 by 2 box. Okay. So I have the square root of 2 minus the square root of 5 on one side. And on the other side, I have the square root of 2 plus the square root of 5. Okay. Now the multiplication box means you need to multiply on the inside. Multiply to fill the inside. Okay, so the thing with multiplying though, we learned this on last week, is you can multiply coefficients times coefficients, and you can multiply radicands by radicands, but you can't multiply a radicand and a coefficient. If it's in front, I can't multiply it with a number on the inside, and vice versa. Okay. So we have to make sure they're both square roots or they're both coefficients. So I have a square root of 2 here and a square root of 2 here. They're both coefficients, or they're both radicands. They're both square roots. So I can multiply those 2. When I multiply those 2, I get the square root of 4. What is the square root of 4? Isn't that a regular number? So that's just positive 2. You can do that now or you can do that later, but since we already know it, it's on our list. It's one of those things you know. Okay, so this guy here is negative square root of 5 times square root of 2. They're both square roots. I can multiply numbers on the inside. So it's going to be negative square root of 10. Okay. Now, the next one is very similar, just positive, right? Square root of 2, square root of 5. It's just they're both positive this time, so I get positive. You can put a plus in the front, or you don't have to. It's up to you. And then the last one, you have a negative square root of 5 and a positive square root of 5. So it's going to be a negative. And you multiply the radicands and you get 25. Well, again, that one we know, right? What's the square root of 25? 5. So it's actually minus 5, negative 5. Okay. Next thing is you're going to write what we get. What did we get in each of the cells? In each of the sections of the box, what did we get? Well, the first one we got a 2, right? We got a 2 here. Square root of 4 was 2. And then the next one we got a minus square root of 10. And the next one we got a positive square root of 10. And then the last one we got a minus 5 or a negative 5. Okay. Last thing, combine like terms. So what do we have that's a like term that we can combine? Negative 5 and 2. Yeah, those are like terms. Those are both coefficients without any roots or anything with them. They're just numbers, constants, numbers by themselves. So negative 5 plus 2 or 2 minus 5 is going to be negative 3. And then we also have another one. We have this guy here and this guy here. These are both like terms. They both have the square root of 10. When we add them together, what's going to happen? They cancel each other out. Yep, they cancel each other out because one is negative and one is positive. And when you add those together, you get 0. So the answer is negative 3. That was the only thing that's left. Okay. So that one we had all square roots. We had all square roots over here. The next one, we're going to mix square roots with coefficients. Do you see that the next one we have? Okay. So they're the same thing. They're exactly the same thing. Square root of 7, square root of 10 minus 7, and square root of 10 minus 7. They're both the same thing, right? Same thing. We're going to do the same, play the same game we were doing before. Coefficients times coefficients. Radicands times radicands. If they're different, they don't multiply. So the first one here, square root of 10, square root of 10. Those both are square roots, so I can multiply those and I make square root of 100. Well, 100's on my list, right? What is the square root of 100? 10, positive 10.
So how do you combine a regular number and a square?
All right, we're going to talk about that right now. So I have a negative 7, no square root, times positive square root of 10. I can't multiply those to make negative 70. You can't do it because one is a coefficient, one is a radicand. You can't do it. So how do I write it? This is how you write it. You write it exactly like that. The purple first, coefficient first, square root next. If a number and a root are stuck together like that, that means multiplication. We just can't multiply them because they're different. One's a square root, one's a radicand, and one's a coefficient. So we're going to do that for the next one. The only difference is, actually there is no difference. They're both the same. Negative 7 times the square root of 10. I can't multiply them because one's a coefficient and one is a radicand. The last one, they're both negative 7, no square root. So I can multiply those to make positive 49. Okay, multiplication's done. Combine like terms. Well, let's see what we can combine. We got 10. We got a negative 7 times the square root of 10. I got another -7 times the square root of 10, and I got a plus or a positive 49 from each of the boxes I have. Okay? Bobby, have your focus up here. Okay? I have that's what I have. So now combine like terms. Well, the easy ones to combine are this guy and this guy here, because they both don't have any square roots, and they both are just coefficients. They're both positive, so you add them together and you get 59. The middle two. Are those like terms? The blue guys? Yeah, those are like terms. So do I combine them? Which do I combine? The sevens, the tens, or both? Just the sevens. Good. Just the sevens. The tens stay the way they are. And I have the square root of 10. Are there any, I haven't checked that, but I should. Are there any doubles inside the square root of 10? Any pairs inside the square root of 10? What's the only way to make 10? 5 and 2, right? Besides 10 and 1. 5 and 2. There are no pairs inside of 10. So I can't simplify this anymore. So that's why I'm done there too. Okay, you should always check those before you're done to see if there are any pairs. Most of the time you can just do it in your head, but make sure you check those, okay? All right, let's try the next one, number 5. Okay, so before we multiply, it says multiply on this one, but before we multiply, so this one's got two terms. The first one's got a -5, and then this one is one term here. 2 is the coefficient, 10 is the radicand. If a coefficient and a radicand are there, they have both, right? The -5 doesn't have the radicand. This one has both. 1 right here has both, or sorry, it's only has a coefficient, and this one has both. What's in front that we don't write? A 1, yeah. So we need a 2 by 2 here. So when you're multiplying, multiply coefficients times coefficients, multiply radicands times radicands. You don't multiply them together. Okay? So the first box, top left, we get -5 times +1, which is -5. Just a regular plain old -5. The next one has both. It has coefficients and radicands. I have a -2 here, coefficient, with a 1 coefficient. I can multiply those guys. That one I can multiply to make -2. This guy has a square root of 10. This guy doesn't have a square root here, so I don't have to, there's nothing to multiply it with, so it's just the square root of 10. Okay. The next one has a -5. That one is a coefficient. -1 is a coefficient. I can multiply those together to make a +5 times the square root of 10. There was nothing up here to multiply the square root of 10 with. Square root of 10, and this one didn't have a square root, so it was just square root of 10. The last one has both, though. The last one has both. So I'm going to multiply the coefficients together. -2 times -1, +2. Square root of 10 times the square root of 10 makes the square root of 100. So it's 2 times the square root of 100. Well, what is the square root of 100? 10, right? So really this is 2 times 10, which is 20. It's really 20. Okay. Combine like terms. What do I got? I got -5 I got negative 2 times the square root of 10. I got positive 5 times the square root of 10, and I got a positive 20. So the ones I can combine, combine. The ones I can't, I can't. So a negative 5 and a positive 20, I can combine those guys since those are both coefficients. So that's 15. And then these guys here, I can combine. One of them's negative, one of them's positive. So I add the coefficients or subtract them, whatever way we want to think about it. And there you go. Okay. And like I said, the square root of 10 is 5 times 2. So I can't, there's no way of reducing it. It stays the square root of 10. That's as far as it can go. No pairs in there. Okay. All right. Last one, and then we'll do some practice. Okay. Okay. So the last one. Here we go. 2 by 2 box. So I have negative 1 and negative 2 times the square root of 6. So that one I have both, coefficient and radicand. The other one I have 6 and positive 3 square root of 150. It has both, coefficient and a radicand. Okay. Negative 1 times positive 6, negative 6. Negative 2 times positive 6, negative 12, square root of 6. Okay. Next one, negative 1 times positive 3, negative 3, square root of 150. Last one, they have both. Negative 2 times positive 3 is negative 6. And then 6 times 150 is 900. 900. Okay, so multiplication is done. Last thing to do is combine like terms. So let me see what I got here. I have a regular negative 6. I have a negative 12 with a square root of 6. I have a negative 3 with a square root of 150. And I have a negative 6 with a square root of 900. You always, always, always want to see if you can simplify your roots. Are there pairs left in there? Okay, so the negative 6, the first negative 6 doesn't have a root. Can't simplify that, right? The 6 right here, what's the only way to make 6? Does 6 have any pairs inside of it? 3 times 2, that's it. So this one is simplified. So these two are simplified. 150, though, is a pretty big number. So I'm going to check 150 and I'm going to check 900 to see if I can simplify those. Okay, so I'm going to do that over here. 150. 150 breaks down to 15 times 10, or 6 times 25. Okay, break this down. So 15 is 3 times 5. 10 is 5 times 2. So it turns out 150 does have a pair, has a pair of 5s. Okay. So 150, so let me rewrite this. Negative 6 minus 12 square root of 6. So what is going to come out of the 150? What's going to come out of the 150 here? It has which pair? So does 150 have pairs? Yes, it does, right here, right? So what's going to come out? The 5, and it's going to multiply with this negative 3, right? So the 5 is going to multiply with the negative 3 to make a negative 15. What stays on the inside? 2 times 3, not 2 and 3, because that's 23, or not 3 and 2, because that's 32. They multiply to be 6. Okay, I'm going to do the same thing with 900, but 900 is a special case. You'll see when you simplify 900. 900 makes 100 times 9, 10 times 10, 5 times 2, 5 times 2. And then 9 is 3 times 3. So when I say 900 is a special case, why is it a special case? What's special about it? There's nothing left. So what do we call those numbers that have nothing left on the inside when we simplify it? Perfect squares. Yeah, 900 is actually a perfect square. Why isn't it on our list? Because we stopped at 14, right? 900 is actually 30 times 30, right? Because if I have a pair of 5s, that's 5. I have a pair of 2s, 5 times 2 is 10. And I have a pair of 3s, 10 times 3 is 30. Okay? So yeah, so 900 is actually a special number. So the square root here is actually 30. So it's going to be 30 times negative 6, which is negative 180. Now everything has been reduced, simplified. Now I can combine what I can combine. Negative 6 and the negative 180 I can combine. Negative 186. And then these two guys have the same square root of 6, so I can combine their coefficients. Negative 27, square root 6. Okay. All right, so today what we're going to do is we're going to do some more practice. We're going to do a couple more problems, but we're not going to do them in your notes like you usually do. We're going to do them. I'm going to pass out some whiteboard markers, and we're going to do them on your desk. Okay. So tape. I'll pass around tape. Tape it in your notebooks. Once you get the tape, pass it to the next person. Pass it to the next row so that everybody gets tape. Okay.